So here we are with revising complete class 12th physics. Let's start with electric charges and fields. Electric charge, positive and negative charges were named by Benjamin Franklin. देख लीजिए. Charging can be done by friction, induction, conduction, and charging by friction. When glass rod is rubbed with silk rod, acquire one type of charge, and silk acquire one type of charge. Properties of charges: two type of charge exist. Like charge repel each other, unlike attract. The body is charged by loss or gain electrons in an isolated system. Total charge remains conserved. Charge exists in distance discrete nature. Q equal to n into E मतलब quantization of charge. Moving charge has magnetic effects along with electric effects. Electric accelerating charges emit radiation. गोल्ड लीफ इलेक्ट्रोस्कोप डिफेक्ट डिटेक्ट चार्ज ऑन अ बॉडी. एक एक्सपेरिमेंट होता था गोल्ड लीफ एक्सपेरिमेंट. उसके अंदर क्या होता था, उसके ऊपर एक रिसीवर था. रिसीवर पे आपको एक चार्ज ऑब्जेक्ट अगर लगाएंगे तो नीचे का गोल्ड लीफ रिपेल करेगा. तो दिखाता है चार्ज है या अनचार्ज है. बट चार्ज या स्केलर एंड एडिटिव इन नेचर. स्केलर क्वांटिटी है चार्ज का एंड एडिटिव टाइप का होता है. कंडक्टर एंड इंसुलेटर. Some substances which radially allow passage of electricity through them are called conductor. Metal, human body, earth. Conductor material which opposes flow of charge through them are insulator. Glass, porcelain, plastic, nylon, wood, etc. are insulator. Earthing, a process of sharing charge with earth, is called grounding or earthing. Charges interaction. Coulomb's law is quantitative statement about force between 2 point charges. Force varies inversely as square of distance between the charges and directly proportional to product of magnitude of two charges, and acts along the line joining two charges. Two charges Q1 and Q2 separated by distance are in vacuum. The magnitude of force between them is equal to K Q1 Q2 by R square. K depends on system of units and medium. In SI unit in vacuum, K equal to 9 into 10 to the power 9 unit of charge is coulomb. F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Epsilon naught equal to 8.854 into 10 to the power minus 12 coulomb square Newton inverse meters to the power minus 2. Force between multiple charges. Force on any charge due to number of other charges is a vector sum of all the forces on that charge due to the other charges. Take one at a time. The individual forces are unaffected by presence of other charges. This is termed as superposition principle of electrostatics. Vector sum of forces is obtained by a parallelogram law of addition of vectors. Force on first charge due to other is given as F1 equal to Q1 by 4 pi epsilon naught N by I equals to 2 Q1 by R1 I square equal to R1 I cap. Electric dipole. An electric dipole is an arrangement of pair of equal and opposite point charges separated by a distance. Direction from minus q to plus q direction of a dipole moment. Electric fields due to dipole. On axis of dipole, electric field equal to 1 by 4 pi epsilon naught 2 pr by r square minus a square whole square. If r is greater than a, then we can eliminate a by r. 1 by 4 pi epsilon naught equal to 2 p vector by r cube. इक्वेटोरियल प्लेन पे सिर्फ सेम ही होगा, यहाँ पे 2 की जगह p बाई आर क्यूब होगा और डायरेक्शन इसका अपोजिट इसलिए नेगेटिव हो रहा है. इलेक्ट्रिक फील्ड ऑफ चार्जेस. एक गार्जेस नहीं चार्जेस है. A charge placed at a point produces an electric field everywhere in the surrounding. When another charge is brought in, field field there acts on it and produces a force. Faraday introduced field concept. Electric field intensity produced by a charge q at a point distance r is given by q. Er equals to 1 by 4 pi epsilon naught q by r square. R cap. SI unit of electric field is Newton per Coulomb. Field intensity at a point due to charge q in space is defined as the force that a unit positive charge would experience if placed at that point. E equals to limit q to 0, q tends to 0, f by q. Field vary from point to point and is a vector quantity. Field can transport energy. Field due to system of charges. Electric field at a point P in space due to system of charges is defined as force experienced by a unit test charge placed at that point. E vector equals to 1 by 4 pi epsilon naught I equal to 1 to n q 1 by r1 square p r cap ip. Polar molecule H2O have permanent electric dipole moment even in absence of electric field. Non-polar molecule methane, carbon dioxide, the dipole moment is zero. A dipole is external uniform electric field. In external uniform electric field experiences torque but no net force. Tau equal to P cross E. Tau equals to PE sin theta. क्यू ई फोर्स इस तरफ लग रहा है, यहाँ पे भी क्यू ई आउटवर्ड्स लग रहा है, माइनस क्यू फोर्स प्लस क्यू फोर्स. इलेक्ट्रिक फील्ड लाइन्स. लाइन ऑफ फोर्स बाय फैराडे. Field lines carry information about direction of electric field at different points in space. Relative density of field lines at different points indicate relative strength of electric fields at these points. Faraday introduced non-mathematical way of visualizing electric field around charge configuration. Region of weak field, region of strong field. Electric field lines properties. It is a way of pictorially mapping the electric field around a configuration of charges. A field line is a curve drawn in such a way that tangent to each point in direction of net field at that point. A field line is a space curve, a curve in 3 dimensions. Field lines of a single positive charge are radially outward. Field lines start from positive charges and end at negative charges. From a single charge, line can start from or end at infinity. In a charge-free region, electric field lines can be taken to be continuous curves without any breaks. Two field lines can never cross each other. और यहाँ पे ये क्यों नहीं क्रॉस कर सकता? अगर टू फील्ड लाइन किसी पॉइंट को क्रॉस कर जाए तो सेम पॉइंट पे दो डायरेक्शन मिलेंगे, टेंजेंशियल दो डायरेक्शन मिलेंगे, जो पॉसिबल नहीं है. सो कभी क्रॉस नहीं करती इच अदर को. Electrostatic field lines do not form any closed loop, but magnetic field lines form a closed loop, because electric field lines inside a conductor is zero. This follows from their conservative nature. Electric flask. Similar to fluid flow, an analogous quantity exists in electrostatic called electric flask. There is no flow of observable quantity. The number of field lines crossing a unit area placed normal to field at a point is measured of strength of electric field at that point. Number of field lines crossing delta S area is proportional to E delta S cos theta. This is called electric flask through area element delta S. Delta phi equal to E dot delta S equal to E delta S cos theta. Theta angle between E and outward down normal to area element delta S. Unit Newton Coulomb inverse meter square. Total flask phi equals to summation of E dot delta S. Approximate sign is because electric field is taken uniform over area element. If delta S tends to 0, then phi equal to integration or E dot ds. Gauss's law. Total electric flux through closed surface is equal to Q by epsilon naught, where Q equals to total charge enclosed by S. Total flux is zero if closed surface encloses no charge. Gauss law is true for any surface no matter what its shape or size is. Q is total charge enclosed by surface. Located anywhere inside Gaussian surface should not pass through discrete charges. Any violation of Gauss law will indicate departure from inverse square law. Application of Gauss law. Electric field due to infinitely long wire E equal to lambda by 2 pi epsilon naught r at distance from linearly charged rod. Field of uniformly charged cell E equal to q by 4 pi epsilon naught r square. R is greater than equal to r, capital R. Electric field due to infinite plate sheet epsilon E equal to sigma by 2 epsilon naught. N is independent of distance from sheet. Directed out for q is greater than 0. Directed inward for q is lesser than 0. E equals to 0, where small r is lesser than capital R. Field is 0 inside cell. ठीक है, अब मैं रीडिंग ना पढ़ के जिस लाइन को समझाने के लिए होगा उस लाइन को सिर्फ समझा दूंगा यहाँ पे, ठीक है। चलिए, electric potential, work done by external force in bringing a unit positive charge from infinity to that point without acceleration is equal to electrostatic potential at that point. Its SI unit is volt. इलेक्ट्रोस्टैटिक पोटेंशियल ड्यू टू अ पॉइंट चार्ज लेंगे यहाँ पे, तो उसका होगा क्यू बाई 4 पाई एप्सिलॉन नॉट आर, सिंपली के क्यू बाई आर। और उसका ग्राफ अगर वी आर का ग्राफ लेंगे तो ऐसा आएगा, पोटेंशियल ड्यू टू अ सिस्टम ऑफ चार्जेस सुपरपोजिशन लॉ। पोटेंशियल एट अ पॉइंट ड्यू टू टोटल चार्ज configuration is the algebraic sum of the potential due to individual charges. Potential due to an electric dipole V equal to P cos theta 4 pi epsilon naught r square. R is greater than dipole strength at general point. Potential on axis of dipole V equal to 1 by 4 pi epsilon naught P by r square. Potential in the equatorial point of dipole is 0. ये याद रखना, यहाँ से डायरेक्ट क्वेश्चन आ जाएगा। रिलेशन बिटवीन फील्ड एंड पोटेंशियल ई इक्वल टू डी वी बाई डी एल, डी वी बाई डी आर भी बोल सकते हैं यहाँ पे। पोटेंशियल ड्यू टू यूनिफॉर्मली चार्ज स्फेरिकल कंडक्टिंग सेल बी इक्वल टू 1 बाई 4 पाई एप्सिलॉन नॉट क्यू बाई आर, वेयर आर इज ग्रेटर देन इक्वल टू कैपिटल आर तक कांस्टेंट रहेगा, उसके बाद ड्रास्टिकली ह्रास होता रहेगा डिस्टेंस के साथ। Q is charge on cell and R is its radius. Potential is constant inside cell and is equal to potential surface, तो के क्यू बाई कैपिटल आर हो जाएगा। तो इक्विपोटेंशियल surfaces, it's a surface with a constant value of potential at all points on its surface. Equipotential surfaces of a single point charge are concentric spherical cells concentrated at the charge. For any charge configuration, an equipotential surface is normal to electric field at that point. No two equipotential surfaces cut each other for dipole equipotential surfaces. और डाइपोल के लिए ये इक्विपोटेंशियल सरफेसेस का एक डायग्राम है. Potential energy is external field equal to q v1 q v2 q1 v1 q2 v2 q1 q2 by k q1 q2 by r. Potential surface external field potential energy of dipole minus pe cos theta minus pe p dot e डॉट प्रोडक्ट करेंगे तो cos theta आएगा. इलेक्ट्रोस्टैटिक of a conductor. Inside conductor electrostatic field is zero, either is neutral or charged. Electrostatic potential is constant throughout volume of conductor and same value as on surface. If cavity is created inside conductor and charge is kept outside cavity, any electric field outside conductor does not enter into the cavity. So cavity of conductor remains shielded. No work done in moving a charge on conducting surface. क्योंकि इक्विपोटेंशियल सरफेस है ना, तो इक्विपोटेंशियल सरफेस होगा तो पोटेंशियल का डिफरेंस जीरो, तो वर्क डन जीरो. व्हेन अ कंडक्टर प्लेस्ड इन एक्सटर्नल फील्ड इलेक्ट्रिक फील्ड लाइन्स आर ऑलवेज नॉर्मल टू कंडक्टिंग सरफेसेस. इक्विपोटेंशियल सरफेस से ऑलवेज नॉर्मल जाएगा फील्ड लाइन, क्योंकि एंगल अगर 90 डिग्री होगा तो वैल्यू जीरो होगा. Dielectrics are non-conducting substances having no charge carrier. Polar dielectric has permanent dipole moment. Example HCl H2O. Non-polar dielectric has non-dipole moment. Example O2 H2. Electric dielectric with polar non-polar molecules develop a net dipole moment in an external electric field. The dielectric is polarized. Dipole moment developed per unit volume called polarization. P equal to epsilon naught chi E xi equal to electric susceptibility of dielectric medium, xi equal to k minus 1 dielectric strength. Maximum value of electric field that a distance dielectric medium can withstand without breakdown of its insulating property is called as dielectric strength. For air, dielectric strength is E equal to 3 into 10 to the power 6 volt per meter. For any capacitor, the electric field do not exceed the breakdown limits. There is a limit to charge amount that can be stored on a given capacitor without significant leakage. Capacitance of capacitor. C is independent of Q and V but depends on shape, size and separation of system of two conductor and also on dielectric separating two conductor. Every capacitor has a limited electric capacity. पैरेलल प्लेट कैपेसिटर, ये फॉर्मूला याद रखना. एप्सिलॉन नॉट ए बाई डी प्लेट एरिया, प्लेट सेपरेशन डी. डाइलेक्ट्रिक इंसर्टेड ऑक्यूपाइंग फुल इन्वर्टेड रीजन के एप्सिलॉन नॉट ए बाई डी के डाइलेक्ट्रिक कांस्टेंट ऑफ सब्सटेंसेस. कॉम्बिनेशन ऑफ कैपेसिटर. चार्ज on plate plus minus q are same on each capacitor. Equivalent capacity decreases. Same potential difference is applied across each capacitor. Plate across not necessarily same equivalent capacity. Equivalent capacity increases in parallel. Equivalent capacity decreases in series. Energy stored capacitor half of cv square qv by 2 q square by 2c. ये तीनों एनर्जी स्टोर्ड का एनर्जी डेंसिटी यू बाई भी से यहाँ पे हाफ ऑफ सी वी और हाफ ऑफ एप्सिलॉन नॉट ई स्क्वायर एनर्जी डेंसिटी. चार्ज शेयरिंग इन कैपेसिटर व्हेन टू कैपेसिटर डिफरेंट पोटेंशियल ज्वाइंट विद पॉजिटिव प्लेट्स टुगेदर एंड नेगेटिव टुगेदर. कॉमन पोटेंशियल इज v इक्वल टू C1 plus C2 by C1 plus C2. फाइनल एनर्जी इज लेस देन इनिशियल एंड लॉस्ट एज हीट and electromagnetic radiation. Delta U equal to half of C1 C2 by C1 plus C2 V1 minus V2 whole square. ये यहाँ से चार्ज शेयरिंग का एक फार्मूला, ये कॉमन याद रखना. C1 V1 C2 V2 by C1 C2. यहाँ पे थोड़ा कॉन्सेप्चुअल भी ध्यान रखना पड़ता है, कभी चार्ज कंजर्वेशन करना पड़ता है. ये भी अच्छा वाला करंट इलेक्ट्रिसिटी से बहुत इंपॉर्टेंट लाइन्स आते हैं. इलेक्ट्रिक करंट Net charge passing per unit time through the area. Current may not always be steady. We define current in general I equals to limit delta t tends to 0 delta q by delta t. Its SI unit is ampere. A cell can maintain a steady current. Drift velocity. The charge carriers like electron move average velocity which is independent of time. This phenomenon of drift and is called drift velocity. Vd equals to minus e small e charge capital E by m tau relaxation time. Although collision of electrons do not occur at regular interval but average time between successive collision is taken relaxation time. सेम चीज़ ही था वहाँ पे। जो दो सक्सेसिव कोलिशन के बीच का पाथ होता है उसको बोलते थे मेन फ्री पाथ। करंट डेंसिटी एंड मोबिलिटी. Current through unit cross sectional area is called current density. It is denoted by J and is a vector. SI unit is ampere per meter square. J equal to sigma into E, energy density equal to n E square tau by m into E. Capital E electric field inside conductor. The relation Ohm's law is in microscopic form. Conductivity is due to mobile carriers. In metals, charge carriers are electrons. In ionized gas, they are electrons and positive charged ions. In electrolytes, they are positive and negative ions. Mobility is magnitude of drift velocity per unit electric field. M equal to mod of Vd by E T tau m. SI units are m square V inverse S inverse. Ohm's law, the current flowing through a conductor is proportional to potential difference across it provided temperature is constant. V is proportional to I or V equals to Ri. R is the resistance of substances. SI unit of is ohm. 1 ohm equal to 1 V ampere inverse equivalent from J equal to sigma E. J current density vector affecting R equal to rho I by A. Material of conductor, area of cross section of conductor, length of conductor. Limitation of Ohm's law. The relation of V and I is not unique. In gallium arsenide, V ceases to be proportional to I. Material becomes non-ohmic material. For a diode, relation of V and I depends the sign V. This material is used to electric devices. I and V, gallium arsenide not obeying Ohm's law, negative nonlinear resistance region, resistivity and its temperature dependence. Materials are classified as conductor, semiconductor and insulator according to their resistivity value. Metals have resistivity range 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. Insulators have resistivity range from 10 to the power 5 to 10 to the power 18 ohm meter. For metallic conductor over a limited range, resistivity is approximately given by rho t equal to rho naught 1 plus alpha t minus t naught फॉर गुड कंडक्टर सेमीकंडक्टर नाइक्रोम. गुड कंडक्टर के लिए देखिए एक टाइम तक ये कांस्टेंट प्रोपोर्शनल, उसके बाद थोड़ा चेंज होता है, ज़्यादा बढ़ जाता है. करंट वोल्टेज बढ़ाने पर भी करंट कम हो जाता है एक पॉइंट के बाद. और यहाँ पे सेमीकंडक्टर पे देखिए कॉपर वायर तो कंडक्टर है. यहाँ पे स्ट्रेट लाइन की जगह थोड़ा कर्व ही नेचर आ रहा है. नाइक्रोम के लिए स्ट्रेट लाइन पर एक फिक्स टाइम के बाद उस टाइम के मतलब 1 वोल्टेज देंगे तो करंट नहीं आएगा. 1.10 से थोड़ा नीचे करंट देंगे, 1 से थोड़ा ज़्यादा होगा तो उसके बाद टेम्परेचर के बाद करंट आना चालू होगा. अच्छा ये सॉरी सेमीकंडक्टर्स के लिए वो ग्राफ हाइपरबोला जैसा आएगा. टाइप्स ऑफ कलर कोडिंग और रेजिस्टेंस. कलर कोडिंग हमारा बात चला गया. फिर यहाँ पे एक अच्छा मेरे पास मैंने याद था एक न्यूमोनिक देखे B. Roy of Great Britain have very good wife and she have gold, silver, wearing gold and silver. और एक निमोनिक था ब्लैक ब्राउन रॉड ऑफ योर गेट ब्लैक ब्राउन रॉड ऑफ योर गेट यहाँ पे वो वाला निमोनिक याद नहीं आ रहा बट बीबी रॉय वाला था यहाँ तक है वेरी गुड वाइफ और सी हैज़ गोल्ड सिल्वर समथिंग वायर बाउंड रेजिस्टेंस तो हो गया ये वाला फिर भी पढ़ लेते हैं मेड ऑफ मटेरियल्स विच आर रिलेटिवली insensitive to temperature. Winding of wires are always alloys, wedge, manganese, constantine, nichrome. Range fraction of an ohm to few hundred ohms. Carbon resistors compact, inexpensive and have higher range. Color coding of carbon resistor cell and its EMF. Cell and its EMF. It is a simple device which can maintain a steady current in electric current. EMF of a cell is potential difference between positive and negative electrode when current is flowing through the cell. डिस्चार्जिंग के समय सेल का वोल्टेज ज़्यादा होता है ईएमएफ के इलेक्ट्रोड का बीच का पोटेंशियल ज़्यादा होता है नेट सेल का वोल्टेज से भी और चार्जिंग के समय वो ज़्यादा होता है क्योंकि इंटरनल रेजिस्टेंस तब क्योंकि डिस्चार्जिंग के समय करंट का फ्लो आउटवर्ड रहता है और चार्जिंग के समय इनवर्ड आर इज कॉल्ड इंटरनल रेजिस्टेंस द एक्चुअल वैल्यू ऑफ आर इज वेरी फ्रॉम सेल टू सेल द इंटरनल रेजिस्टेंस ऑफ ड्राई सेल इज हायर देन इलेक्ट्रोलाइटिक सेल combination of resistor. The resistors are sometimes joined together and there are simple rules for calculation of equivalent resistance of such combination. Series combination, if only one of their end points are joined, R equivalent R1 R2 parallel में ये फॉर्मूला होता है R equivalent 1 by R equivalent equal to 1 by R1 plus 1 by R2. Electrical energy and power. Electrical power equals to I square R equal to V square by R equal to IV. That is energy set by ions and atom heat up the conductor amount of energy distributed at his per unit time called power loss. R resistance current flowing through it. For long distance transmission power loss is minimized by transmitting it at high voltage. Kirchhoff's rules for complicated electric circuits to determine all the currents and potential differences. Kirchhoff formulated two laws. Junction rule: at any junction, sum of all currents entering the junction is equal to sum of currents leaving the junction. Mesh or loop rule: the algebraic sum of charges changes in potential around any closed loop involving resistors and cell in the loop is equal to 0. Binding or re-rotation of wire does not change the validity of junction law. Combination of cells. Cell can be grouped in series or parallel depending upon current requirements. In series, two cells of EMF E1 and E2 with internal resistance R1 and R2. The combination can be considered as one of cell of EMF equal to equivalent internal resistance are equivalent. In parallel combination, E1 R1 plus E2 R2, नहीं सॉरी, E1 R2 plus E2 R1 by R1 plus R2, R equivalent equal to R1 R2 by R1 plus R2। व्हीटस्टोन ब्रिज का काम क्या है? व्हीटस्टोन ब्रिज से हम नॉन 3 रजिस्टर के हेल्प से अननोन एक रजिस्टर का वैल्यू निकालते हैं। व्हीटस्टोन ब्रिज in its balance condition provide a practical method to determination of internal resistance. If R1 and R2 are two resistors in first and second arm and R3 in third arm, R3 is kept on changing till galvanometer shows no deflection. The bridge then balanced, and from balance condition R4 is known. R4 equal to R3 into R2 by R1. The value of resistance is determined knowing other three resistor. Meter bridge, it is based on Wheatstone bridge with some principle. As Wheatstone bridge is used to calculate unknown resistance, R is balance condition. R equal to S into L1 by 100 minus L1. Percentage error in R minimized by adjusting balance point near the middle of bridge. Moving charge and magnetism. अब से हम सिर्फ फॉर्मूला और छोटे बड़े कंसेप्ट पढ़ के चलेंगे, इतने बड़े बड़े लाइंस को रीड ना करके जो कहना चाहते हैं वो समझेंगे। इट इज स्पेस और स्टेट। लॉरेंस फोर्स क्या था? एक चार्ज अगर किसी वेलोसिटी से इलेक्ट्रिक फील्ड में मूव कर रहा है तो उसके ऊपर कितना फोर्स लगेगा, तो वो होगा इलेक्ट्रिक फील्ड का और मैग्नेटिक फील्ड का सम। इलेक्ट्रिक फील्ड का क्यू ई, मैग्नेटिक फील्ड का भी क्रॉस बी। मैग्नीट्यूड का चार्ज के ऊपर डिपेंड करता है, नेचर के ऊपर, वेलोसिटी के ऊपर। व्हेन चार्ज रेस्ट इट कोई एक्सपीरियंस फील नहीं करेगा। व्हेन चार्ज इज मूविंग पैरेलल टू मैग्नेटिक फील्ड इट डज नॉट एक्सपीरियंस any mechanical force. Motion in magnetic field. In uniform magnetic field, charge particle can have three types of path. Straight line when B is parallel to V, circular path when V is perpendicular to B. Perpendicular force act as a centripetal force and produces a circular motion perpendicular to magnetic field. Circle radius of circle R equal to mv by qb, ये इम्पोर्टेंट था। कहाँ से आएगा ये? एम वी बाई आर स्क्वायर इक्वल टू क्यू बी कर देंगे, क्यू वी बी, तो यहाँ से आ जाएगा। Helical path, velocity v and b are inclined at angle not 0, not 90, not 180 degree. Velocity component along magnitude remains unchanged due to other component. Motion is circular, combined path is helical motion. Omega equal to qb by m. P equal to 2 pi m v parallel by qb. Velocity of velocity selector. वेलोसिटी सिलेक्टर का कॉन्सेप्ट क्या था? व्हेन इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड्स आर क्रॉस्ड, velocity of particle is perpendicular to both fields and particles with speed v equal to e by b pass undeflected. This principle is employed in mass spectrometer. साइक्लोट्रॉन क्या है? साइक्लोट्रॉन पार्टिकल एक्सेलेरेटर है। A machine to accelerate charged particle or ion to high energy. Cyclotron uses both electric magnetic field in combination to increase kinetic energy of charged particle. Frequency of revolution of charged particle is independent of its energy. Frequency F equal to qb by 2 pi m. The frequency is called cyclotron frequency. The frequency of Uh, electric field is in resonance with cyclotron frequency. Final kinetic energy of ion ek equal to q square b square r square by 2m, r equal to radius of d. इट्स ऑसिलेटर ऐसे ऐसे घूमता रहेगा देख टाइम पे इस पॉइंट से बाहर आ जाएगा, तब बहुत स्पीड होगा उसका. Biot-Savart law. According to this law, the magnetic field is at point due to a current element of length dl carrying current L at distance r from element. dB equal to mu I dl sin theta by 4 pi r square. Theta is angle between dl and r. Magnetic field on axis on circular coil B equal to mu I r square by 2 r square plus x square by whole to the power 3 by 2, where r equal to radius of coil, x distance along axis from center of coil plane. At the center of loop x equal to 0, b equal to mu naught I by 2 r. Field lines from closed loop around the circular wire. Ampere's circuital law states that integration of B dot dl equal to mu naught I, where I refers to current passing the loop through open surface S. The sign of current is determined from right hand rule. If B is directed along tangent to Amperian loop of perimeter L and field is constant in magnitude, BL equal to mu naught IE, IE equal to net current enclosed by closed loop. Magnetic field due to solid conductor. A long straight wire with circular cross section of radius a. Magnetic field in region R is lesser than a. B equals to mu naught I by 2 pi a square r. B is proportional to R. B is proportional to 1 by r. Magnetic field in region R is greater than equal to a. B equal to mu naught I by 2 pi r. Magnetic field due to a line current. Magnetic field at a distance r from straight long infinite wire carrying current I, B equal to mu naught I by 2 pi r. Field lines are circles concentric with wire. Direction of magnetic field. The rule is called right hand thumb rule. Grasp an wire in your right hand with your extended thumb pointing the direction of your current. Your fingers will curl around the direction of magnetic field. Long solenoid. Magnetic field inside long solenoid B when solenoid carries current I is beta equal to mu naught Ni. N equal to number of turns per unit length for a toroid. B equal to mu naught Ni by 2 pi r. N total number of turns and r average radius. Mechanical force on a current carrying conductor. A current carrying conductor of straight length L carrying current experience I, F equal to I into I cross B, but if wire is of arbitrary shape, F equal to I dl cross B. Summation can be converted into integration in most cases. Force between current carrying wires. Two current carrying conductors placed near each other experience magnetic force. When conductors are parallel, F equal to mu naught I1 I2 by 2 pi d into L. Force on one conductor of length L due to current in other at separation D. Parallel currents attract and anti-parallel currents repel. The results are in accordance with Newton's third law. Torque on current loops, torque on magnetic dipole, tau equal to mb sin theta, tau equal to nia sin theta. Any planar current loop is equivalent to magnetic dipole of dipole moment. Magnetic moment of revolving charged particles. Magnetic moment associated with revolving electron with speed v in a radius of circle r is mu equal to negative of e v r by 2, mu equal to minus e by 2 me into j cap, where j is the angular momentum of the electron. For electron, angular momentum is opposite in direction to magnetic moment. In general, for any charge q, angular momentum and magnetic moment are in same direction. Mu by j equal to e by 2m. This is called gyromagnetic ratio and is constant. Minimum value of magnetic moment is called Bohr magneton. Mu m equal to 9.27 into 10 to the minus 24 a meter square. Moving coil galvanometer. Torque due to radial magnetic field on loop of area A with n number of turns carrying current I, tau equal to NIAB. Deflection on scale phi equal to NAB by KI. Quantity in bracket is constant for galvanometric. This makes linear scale. Current sensitivity galvanometer ये important है. SI equal to phi by I into NAB by K. Current sensitivity can be easily increased by changing number of turns in voltage sensitivity. Deflection per unit voltage SB by phi by V NAB by K into 1 by R. Galvanometer conversion ammeter. Modification of galvanometer by connecting a low resistance in parallel. Voltmeter to measure voltage any section of circuit it connected in parallel when a large resistance is in series with galvanometer becomes a voltmeter. Rogers spiral. The current passes through spring. The effect is length of parallel current produces attraction decreasing spring length. Oscillation start and continue with tick tick tick. Magnetism and matter. Bar magnet. Magnet of bar suspended in its direction. Like poles repel and vice versa. Monopole do not exist. Continuous closed loop. Tangent given represent direction. क्लोज लूप फॉर्म कट करेंगे ट्रांसवर्सली लेंथ का तो m/2 हो जाएगा. बार मैग्नेट इक्विवेलेंट सोलिनॉइड म्यू नॉट टू m/4 pi r3. मैग्नेटिक मोमेंट ऑफ सोलिनॉइड m n I into 2l into pi a square. बार मैग्नेट इन यूनिफॉर्म मैग्नेटिक फील्ड tau equal to m cross b. Torque um equal to minus m dot b minus mb cos theta. Potential energy theta equal to 0 degree. Most unstable position theta. Most stable position theta equal to 180 degree. Most unstable position. Time period of oscillation of a magnet when freely suspended in uniform magnetic field equal to 2 pi under root I by mb. ये important रखना I by mb. B equal to 4 pi square m t to the t square. The electric analog. Magnetism B. Electrostatics E. Magnetism M. Electrostatics P. Magnetism mu naught 1 by epsilon naught. Magnetism है tau equal to m cross B. Electrostatics equal to P cross E. Magnetism B axial equal to के पकड़ के k 2m k बाई आर क्यूब. यहाँ पे भी 2k बाई आर क्यूब सॉरी 2k p. गॉस लॉ फॉर मैग्नेटिज्म. क्लोज इंटीग्रेशन ऑफ b डॉट d a इक्वल टू 0. आइसोलेटेड मैग्नेटिक पोल्स डू नॉट एग्जिस्ट. नेट मैग्नेटिक फ्लक्स is 0 for any closed surface. Magnetism and magnetic intensity. M equal to m net by v. Net magnetic moment by volume. Net field in the interior of solenoid B equal to b naught plus bm. Field in free space. Contributed magnetic core mu naught h. B equal to mu naught plus m into h. B equal to mu naught plus 1 into 1 plus x. 1 by 8 इसको बोलते हैं हम काई बोलते हैं सर. 1 by क्लाई into h. ये बहुत रिलेटिव का 1 प्लस एक्स इम्पोर्टेंट है. पैरामैग्नेट magnets and electromagnet. Paramagnetic magnet material should have high retentivity, high corrosivity, high permeability. Material used for making this material are alnico, cobalt, steel, ticonal. These materials retain their ferromagnetic property for long period of time. Material should have low retentivity, high permeability, low coercitivity. Material used for making these magnets is soft iron. Magnets are used in electric bells, loudspeaker, and telephone diaphragm. Hysteresis loop, retentivity value B at H equal to 0, coercivity the value of H per which net magnetic field becomes 0, energy is lost in the form of heat during complete cycle of magnetization and demagnetization. Hysteresis curve of soft iron is tall and narrow. Hysteresis curve of steel is broad. Magnetic properties of material. Zeta equal to -1 is less than zeta is lesser than equal to 0. mu r 0 lesser than equal to mu r is lesser than by 1. ये डायमैग्नेट इसका प्रॉपर्टी है. म्यू नॉट से छोटा है. पैरामैग्नेटिक के लिए ये 0 से के बीच में लाई करता है. के इज स्मॉल पॉजिटिव, बट ये म्यू 1 से 1 प्लस के बीच में लाई करता है एंड म्यू इज ग्रेटर देन म्यू नॉट. फेरोमैग्नेटिज्म, जीटा एक से बहुत बड़ा होता है, म्यू आर से भी बहुत बड़ा होता है, 1 से बड़ा होता है, और म्यू नॉट से भी बड़ा होता है. Movement in uniform magnetic field, weak tendency from strong to weak magnetic field, from weak to strong magnetic field, from weak to strong magnetic field. Bismuth, Au, Pb, Si, H2, NaCl, N2, Ag, superconductor, aluminum, sodium, oxygen, Stp, platinum, tungsten, ferrous, cobalt, nickel, FeO3 and gadolinium. फील्ड लाइंस डायमैग्नेटिक का ऐसा होता है, पैरा का ऐसा, फेरो का ऐसा. ऐसे ये तीर रिपेल कर रहे हैं, ये तीर को थोड़ा अट्रैक्ट कर रहे हैं, ये तीर को एकदम ब्लैक होल जैसा अंदर बुला रहा है. ये देख रहा, आपको डायग्राम नहीं दिख रहा, सॉरी, ये देख लीजिए. ससेप्टिबिलिटी इंडिपेंडेंट ऑफ टेम्परेचर यहाँ पे लाई करता है एंड इन्वर्सली प्रोपोर्शनल to Xm where C is Curie constant. ये ग्राफ थोड़ा ऐसा आता है. एंड Curie temperature, the temperature at which ferromagnetic substance become paramagnetic. Disappearance of magnetization with temperature is gradual. Beyond Curie temperature, susceptibility obeys Curie-Weiss law. Zeta m equal to C by T minus Tc. T is greater than Tc. Tc for iron is 1043 K. Tc for nickel is 631 K. Faraday's experiment. First experiment, relative motion between a bar magnet and wire loop produces a small amount of current. Second experiment, if one coil is connected to a battery and another coil moves towards bar away from it, electric current is produced in neighboring cell. Current is induced in coil C1 due to C2 current carrying coil. Third experiment, galvanometer shows momentarily deflection when tapping key is pressed. Magnetic flux through a surface of area A is placed. Uniform magnetic field B written as phi B equal to B dot A BA cos theta. Non-uniform magnetic field phi equal to integration of B dot dA. Faraday's law of induction. Conclusion of experiments was formulation of laws. The magnitude of the induced EMF in a circuit is equal to the time rate of change of magnetic flux through the circuit. Mathematically, the EMF induced is given by epsilon naught equal to minus d phi beta by dt. Negative sign indicates the direction of E and hence the direction of current in the closed loop. The loop contains n number of turns. Change of flux is associated with each turn. epsilon naught equal to minus n into d phi beta by dt. The induced EMF can be increased by increasing the number of turns of closed coil. Lenz law, the law gives the polarity of induced EMF. The polarity of induced EMF is such that it tends to produce the current which opposes the change in magnetic flux that produced it. The law, in accordance with the law of conservation of energy, illustration of Lenz law. Motional EMF, straight conductor in motion in uniform time independent magnetic field. Slider B equal to ELV EMF across rod. I equal to E by R BLV by R. Delta Q equal to delta phi B by R. Mechanical energy, which is indeed to move arm, is converted into electric energy, then to thermal energy. Rod rotated about one end. Fleming's right hand rule. ये बहुत बहुत आता है ये क्वेश्चन, इम्पोर्टेंट मतलब 2-3 स्टार मार के रखो।